Hello everyone, welcome back to the channel, and this is going to be episode 16 of my Yao Tips series, and this will be on 6x6 cancellation of commutators for last two centers. So let's get started. Okay, so about cancellation into commutators, I talked about it in the last video that I made on 5x5 cancellations, and if you want an explanation on that, and when you can cancel, you can check out that video. I don't think I'll go over it again in this video because I already went over it before. So let's get started. The first case is the most basic one, where you have this bar that needs to go in here and this piece that needs to go here. And also 6x6 is where this cancellation stuff can get really complicated, so just a heads up. So how you solve this, the most basic case is, can pretend like you're inserting that, but on your way inserting that, you slice up this layer, you bring down that, you prime, and then undo the slice. So fast would be something like that. Second case is essentially the same as the last one, but you're slicing up a different layer, and the explanation is basically the same. So instead of slicing up this layer, you're going to slice up that layer. So here we go. And faster. Okay, so here's the next case. It's when you have this corner center that can pair up with this 2x1, and you have this oblique that's detached from the bar. And so you can think of it like inserting this and then doing the commutator after, but you can do that in one step like this. And faster would be that. Undo the slice. And one more time slow. Alright, so here's the mirror of the last case, and the explanation is basically the same. So this case can be solved like and faster, and one more time slow. Moving on to the next set of cases. This is where this is obviously another cancellation case, but it's when you have these three here, and you can compare this series of three pieces like that. And then how you can solve this case is wide R and slice up this layer at the same time. For the cancellation, do U, wide R prime, U prime, slice back. This one is a little bit more awkward to execute, but I think it is faster than doing that and then doing a commutator. Basically saves the 3 moves, or 6 moves, I don't know. And fast. And then one more time slow. Okay, for this next case, it's basically the mirror of the last case, but here I think you have a little bit more. You have another option depending on which one is whichever one is easier for you to execute. So same explanation as last time. You can do wide R and slice at the same time. U prime, wide R prime, U, slice back. Or this is the execution I prefer because it's more comfortable for me. It's to do wide R, U2, slice this layer, U, wide R prime, U prime, and slice back. So here's the first execution faster. And the second one. That's that. There we go. And for that one, you just need to experiment to see which one you like more. Okay, so next case, this is literally the same as the 5x5 case, and I don't think I want to explain it again. So here is the algorithm where you can cancel two pieces instead of just one this time, and it goes like R wide, U, slice 2, U, R y prime, U prime, like that. Now I don't do this for 6x6 because I find this slice of the two layers is very risky. So for this case, I like to do RY D2, RY prime, and then insert. But if you like the other way, then go for it. Moving on to the cases where you can slice two layers at once, we have this case, which is pretty annoying in my opinion. So instead of solving it like this, inserting this pair of three pieces and then doing a commutator for the last one, you can do R wide, U, U prime, and then slice these two layers like that, and undo that, and faster. So this is basically kind of like a block commutator, but with a corner and an oblique instead of two obliques like you would on, or two edge centers on 7x7. So yeah, one more time. Here's the mirror case of the last one, and same explanation. So this all goes like and faster. Can't even execute it. That. So it's basically the last one, but instead of doing U prime, you do U, and that solves that. Next is this case where you have two 2x1s that are beside each other like this, and this is like the 5x5 case where you're inserting this, but on the way you can also cancel on to commutator to solve these two. So how this would look is R wide U, slice, U, R wide prime, U prime, slice back, and faster. Moving on to this next case. So again, when you have 2x1, and then here you can instead of inserting one of them and then doing the commutator, or like doing that and then solving the last piece, you can do R wide U2, slice, U, R y prime, U prime, slice back, and faster. moving on to some cases where, if for whatever reason, you're solving the outer bar first. So this case is definitely less common than the other ones, but it's when you have this 2x2 here that needs to go here and everything else is solved. So the way you can solve this is line it up like this: slice u prime, slice these two layers, u prime, slice back, u, slice. And faster would be something like that. I don't usually use this case much, so that's why I'm slower at it. So yeah, here's the next case. So it's when you have these two like this, and then this pair of inner corner centers. So you could do that and then solve this commutator like that, but a faster way would be u prime slice u prime r wide u prime slice back, and then do that. This rarely comes up in my solves, so I'm going to be slower at it, but here it is in full speed. Like that. Okay, for this case, you can solve it. It's when you have this, which can be paired like that, into the commutator, but instead of doing that, you can do wide move, u prime, slice, u, and that. And faster would be like something like that. There we go. Here's the next case. So you can do the slice to pair up this and then insert like that, but instead you're going to do slice u2 r wide u prime, slice down u r wide prime, like that. And then faster, here's that. And finally, these last two cases will be the mirrors of the last two cases that I just showed you. So you have this, and pair up the bar, and you can insert like commutator like that. But for this case, you can do like that, and faster. There. And here's this case. I think this is the last one for now, but you can pair up this and insert, but instead of doing that, you can do slice u2 r wide u, slice down u prime r wide prime, and faster. And there we go. So I think that's all the cases that I know. I might have missed one or two, but anyways, that's the video for today. If you enjoyed, please consider subscribing and sharing this video, and I'll see you in the next one.